All right, next property that may or may not be exhibited over different operations such as addition, subtraction, multiplication, and division is the commutative property. The commutative property just means that if I take this operation, I take a number or an element, I guess, with another element, and then I flip the order in which I put the elements together, whether it be via addition, subtraction, multiplication, division, or what have you. If I switch the order in which the operation is performed, does that actually change the value, or does that value stay the same? And so commutative, that's like a big word, especially for young kids that are in elementary school. So I always like to say, and it's a pretty well-known way to remember this, is that let's say you have a nice, pretty way to drive to work and then a short way home. That's going to take the same amount of time as if you take the long, pretty way to work and the short way home. So it doesn't matter. So when you're commuting in a car, if you take the long way and then the short way and then the short way and then the long way, it doesn't matter. It's the same distance driven that day. Okay, so let's explore this again with our different familiar operations. So let's go with addition. We're going to start with addition. All right, so if I have two numbers like A plus B, is that always the same as B plus A? You can try a few things out and see if it holds. So like, does 3 plus 2 turn out to be the same thing as 2 plus 3? You can even try like its identity. So does 0 plus 7 equal 7 plus 0? Yeah, this is working out fine. What if I use some negatives? Is that going to change things at all? Negative 2 plus 1, does that equal 1 plus negative 2? It does. And I can keep playing this game and it'll always work out. So with addition, an axiomatic property of it is that it is commutative. So yes. I don't need to find an identity, so I'm just going to check it off yes. That is satisfied for addition. Now we're on to subtraction. And I want to know if A minus B is always going to be the same as B minus A. It actually only works out if A and B are the same, right? So yeah, 7 minus 7 is the same as, let's flip the order. Well, they were the same, so it didn't really do much. But yeah, it's both 0. But if we try something a little different, like 2 take off 1, is that the same as 1 take off 2? No. Or you could put 0, or just experiment with your own numbers and find a way to see that the commutative property is not being held over the operation of subtraction. So that one, I'll draw a little sad face. No, he did, the commutative property did not hold over subtraction. So sad. All right, now multiplication. Is A times B always going to be B times A? Axiomatically, yes, right? So you could try something like 9 times 1 is the same as 1 times 9. 3 times 2 is the same as 2 times 3, and this can keep going all day. So it's axiomatic here too, that it doesn't matter if I have 2 groups of 3 or 3 groups of 2, or 7 groups of 1 or 1 group of 7. So it doesn't matter the order in which I apply the numbers with the operation. So with multiplication, this is preserved, right? So it is commutative. Check. And then division, lastly. Is A divided by B the same as B divided by A always? Don't think so, right? So like 6 divided by 2, that's just 3, but is that the same as 2 divided by 6? Well, if you had like $2 and you had to split it between 6 people, not everybody gets even one whole dollar, right? But if you have $6 to split amongst 2 people, then it would. So this side is less than 1, this side is more than 1. So they're not the same. That's just me driving down the point that these are not the same. So does division hold this property? The answer is no. And we're seeing that same pattern, right? So with division, the answer is no. So again, the traditional operations do satisfy it. The inverse operations, that's a little bit more advanced, but the inverse operations do not have the commutative property exhibited.